Okay, so this next lesson is still obviously on the subject of electronics and transistor based circuits and transistor switching, but we're going back to have a wee look at sensors and sensor design in this lesson. Okay, so this lesson is about something that we can do to make sensors a lot more user friendly. So here we have a circuit, and hopefully you guys should know exactly how this circuit works at this stage. So we've got a darkness sensor, and that's feeding a signal to a transistor. The idea being that when it's really dark, we should saturate this transistor and the motor will come on. So this could be something like for automatic blinds again, right? I'm just sticking with simple, applications of this engineer. So what we've got here is two protective components, the base protection resistor to protect the transistor from too much current from supply, and a diode across the electromagnetic output device, in this case a motor, and that basically protects the transistor from back EMF that is generated when we switch the motor off. Okay, so I've got a graph in here that shows us the speed of the motor, so that we can see when the motor's on and when the motor's off. So what we've got here is, as light level drops, that motor should come on, and you can see that the system works really well. When darkness happens, the motor comes on. Let's just get that graph to show us what's actually happening. Yeah, you can see that the motor speed actually responds to light level, and that's not really what we want at National 5. We want this thing to switch, but it's okay, this thing's doing its job, right? Now here's the issue. The issue is that that motor starts turning as soon as light level drops even a little bit. So if this was automatic blinds, that would mean that the blinds would start closing if, for instance, a cloud went in front of the sun. And that's not exactly what you want. The system is far too sensitive to changes in light. That motor's coming on straight away. You don't really want the motor to come on until the light level's like, maybe down here or something. So this is the way it works right now is as soon as that light level drops, it would seem that this voltage is breaking 0.7 volts, so it's at 0.698, it's nearly at 0.7 almost immediately. We want to change that balance. We want to change that voltage for that resistance. Obviously we can't do anything to this guy because this guy changes with light level, so it's this guy that we can change. So we can change the value of that resistance there, and that will change the response of the sensor. So I'm going to start messing about with this value. So let's say we set it to, let's set the light sensor to the place where, let's say that's where we want the motor to actually be coming on. So any less than that, we want it to be off. So you can see that the speed of the motor here, if I change this resistance value, hopefully we want the speed to be 0 at this point here. So I'm going to start increasing that resistance. You see the speed dropping, it's not going as far as 0, so let's do it again. Close. Oh, I put 155 in. Oh, silly. I thought I was putting 15 in. Yeah, still too high. End up at something like 50. Every time you increase it, the changes are getting less and less. Right, so I'm just going to go for 50, and we see that drops all the way down, and the motor stops spinning. And what that means is that for all of these values of light level, the motor will remain off, and then the motor won't come on until it gets properly dark. There it goes. Yeah, so I've changed the sensitivity of that sensor by changing the value of that resistance. That's kind of an important point. Yeah, in fact, rather than draw the circuit, I'll have a bunch of poorly drawn circuits in there. So this resistor the resistor in the sensor controls sensitivity. So we saw that at the start this sensor was too sensitive to light. We were at 0.7 volts as soon as light started to drop. Bear in mind this is a darkness sensor, so I suppose you could say it was too sensitive to darkness. So then we had to change the value of that resistance to control the sensitivity of the sensor to make it more usable. In this instance, high resistances result in low sensitivity, but that might not be the case if it was a light sensor. It might actually be the other way around. You would have to experiment with that. But what I do want to draw your attention to is this idea that if we have to be able to change that resistance in order to affect changes in sensitivity, how does the user do it? So this is a simulation of a circuit, but if we actually build this in real life and we put a 50 kilo ohm resistor in there, and the user finds that it's because of the way the light is shining on their house or whatever, that the sensitivity isn't quite right and they want to alter it, we can't expect a user or a consumer to be taking resistors out of electronic circuitry. We can put a component in there that is a variable resistor. So I can take that guy out. What is that? That was a fixed resistor. So I'll put it in there. And there's a component called a variable resistor. So a variable resistor doesn't look anything like a normal resistor. It's like a plastic block with a wee screw head on it. Whenever you see a component with a black arrow across it like that, that means there's something about it that's user adjustable. In this case there's a wee screw on there, and we can adjust that screw to change the resistance of this resistor. So I'm going to give it a maximum of 100 kilo ohms, and that would mean that the user can just turn a screw on that to give them any value they want. So including a variable resistor in the sensor allows the user to change the sensitivity of the circuit. So like for instance, let's just put this into a graph, the kind of graphs that we've talked about before, right? So let's say that's light level, I'm just going to wee pen, and that's the voltage out of the sensor. So if this is a darkness sensor, then we would expect to see a high voltage at low light levels and a low voltage at high light levels. We expect to see it going that way. So that's a darkness sensor. The only thing that tells us that this is a darkness sensor on this graph is the fact that the gradient of the line is going that way. Okay, if the gradient of the line was going that way, then it would be a light sensor. So because it's the gradient going that way that tells us it's a darkness sensor, that means that that's also a darkness sensor. That's a different trace. What's the difference between these two? And equally, well, that's a darkness sensor. Yeah. The difference between these is obviously the gradient of the line. In real terms, that's the sensitivity of the circuit. You can see that for the orange line, for a very, very small change in light level, you get a massive change in voltage. I don't know if you understand that. Let's see if I can use this wee guy here to explain this to you. So for a change in light level, from there, try to get this parallel to there, so there's the change in light level there. The orange trace gives you that much. Oh, this wee pen thing's just killing me. So for that much change in light level, the orange trace gives you that much change in voltage. Compare that to the same light level change on the blue trace. blue trace only gives you that much change in voltage. Okay. So for the same change in light level, the orange voltage will change that much. For the same change in light level, the blue one will only change that much. That's the difference between the gradient of line, and that's sensitivity. This is what I'm talking about when I'm talking about the sensitivity of the sensor. We want the user to be able to alter the sensitivity of their input sensors, and that's why we introduce the use of variable resistors in there. Swap this out for a variable resistor. Oh, what's going on here, man? Swap for a variable resistor to allow for control sensitivity. Then that's the same whether it's a hot, cold, light or dark sensor. The resistor on the other side, you've got your LDR or your thermistor doing its job, and normally we would have had, previously we would have had a fixed resistor in there, but from now on you're going to draw in variable resistors. Okay, so that it just looks like a resistor, except it's got that arrow across it, just drawn like that. It's a variable resistor. Okay, we put them in to allow for control of sensitivity. So we're approaching having a very complete knowledge of really effective electronic circuitry here. Okay, and this is like, this is closed loop. I'll relate this after we do the next bit. I'll relate this back to our closed loop system stuff that we started engineering science with. And we're now approaching the end of electronics in terms of the theory. We've still got some maths to do, but as far as the theory of electronics goes, we're approaching the end here. So, at this point, you've amassed quite a lot of knowledge on these circuits, and I'm still asking for these explain questions. So here's another 2 explain questions where I want you to explain the operation of this circuit, and I want you to explain the operation of that circuit. I want you to refer back to the two previous presentations where I talked about all this kind of stuff. I also want you to refer all the way back to this. I gave you an example explanation of this circuit. Okay, this was the basis of what we started with. What's missing from this circuit? And incidentally, I gave you that example because I wanted you to describe the operation of the 3 circuits that you had designed here. And the 3 circuits that you designed in those questions were essentially going to look like that with a different sensor and a different device here. Okay, so with that explanation about the operation of the sensor and the operation of the transistor, you're adding in all of this information. And I've already asked you to kind of add that in here and here. So this last exercise, not the last exercise, but this most recent exercise, basically asking you to put it all together. So you're going to have to explain the operation of this sensor. You're going to have to explain why this guy is variable. You're going to have to explain what he's doing there. You're going to have to explain what he responds to using the correct terminology. You're going to have to tell me how and why that comes on, and the name of it all, explaining fully the operation of this circuit. And then the same for this one. And the only difference between the two is that this one's got that, and I want you to make sure you explain to me why it's got that. So there you go. That's the kind of layout of this exercise. So go ahead and do this one now. Thank you. If I can turn this off.